Hi guys, welcome to Android tutorial from DURGASOFT. And this is Sandeep again, and let's talk in detail about the Android software stack that we actually ended up in the previous tutorial. And each of these layers, let's talk in detail. And the very first is the application layer, where your whole applications will be sitting on. So each and every application that you see on your phone, which is visible to your eyes on your phone screen, is an application. So you generally have a chance of seeing application layer and application framework, which is actually in middle layer, which will help you to have a seamless environment when you're using any kind of application. As I spoke, when you're using any contacts will be retrieved or will be providing by content providers. So in the same way, window managers, where it will be responsible for showing you windows and all. And let's go on with first the home applications one, and it provides you a set of core applications. So application layer is not only the applications that a user develop and simply he run. There are some core applications that comes along with the Android OS. Something like email client, SMS program, where you see your SMSs coming in and going out, and calendar, that is which is of a core application, and maps, where the maps, now we self call it as Google Maps, and browser, that could be any browser. As of now, we see Google Chrome browser, which is coming by default into any Android smartphones. So, and contacts, something which is again a core application. So apart from this contacts and all, there are other applications that comes into this this program, or the core applications category in your phone. When you don't actually download them on your own, they actually been in your phone by default. And the best part of these applications is that you will be never able to uninstall any of these applications from your phone with user permissions. And all the applications, I'm not only talking about the core applications, user applications, and any kind of applications that we see are actually being developed using Java language, which means Java is something like you talk to the Android SDK or to the mobile, is the language that you speak is Java. So of course, after Java we see C#.NET is also coming into the picture. Now we see Xamarin and all other call it as third party apps developments, or you call it as cross platform, anything you may. It has been developing a cross platform Android SDK, that is which actually accepts C#.NET language in order to communicate, which means that developer can develop it or write the code simply in C#.NET, and still you can make an Android application to run on it. Of course, there are so many things that we are going to learn on that area when you speak about how and why actually Android accepts C#.NET as its language apart from Java. Of course, we are not getting into that thing now, but so one of the information that I has to tell you, Java is the language that you write the applications by default. So if you want anything, some customized other languages, you use C#.NET. And most of the application framework access the application, I mean will be accessed by core libraries through Dalvik, which means that applications or application framework accesses these core libraries. Core libraries will actually consist of all the libraries that were being useful, and core libraries is generally written in C or C++ libraries. So where we call it as NDK, Native Development Kit, generally used for gaming application development in Android. And it has been using the core libraries, or the application framework uses or access the core libraries through Dalvik virtual machine. So VM stands for virtual machine. Dalvik is the person who actually developed DVM. And what is DVM, and what is the way that DVM does here, or what is the work that DVM does here in Android platform, is DVM is something very similar to JVM, that is present in Java. So we know Java virtual machine is very responsible for making your applications, or compiling your applications and execution of your Java applications, which means the bytecode is being generated at JVM level, or it is at least converted into bytecode by JVM. So in order to use the same kind of bytecode, as we are writing the complete Android application development in Java, we are being using the same compilers and the same kind of technique even here. So the bytecode that comes is being executed in order to see the replay, or in order to see any kind of action that happens on your Android mobile. But why, if JVM is already existing and if it uses the same kind of technology or same kind of way that Java does, why should we need JVM? Because JVM bytecode is something very heavy. It's not something very related, or that it is being considered for mobile phones where the memory and the hardware or the RAM, everything is limited. When you talk about the desktops and laptops, you'll have incredibly high amount of RAMs and data or memory available. So JVM doesn't actually care much about the limited resources there. Of course, it does up at certain level, but it's not completely considering the mobile applications or any kind of low level devices. Low level, I mean low level is that it's not something which is completely limited resource devices. So DVM is something that it also converts the whole code into a bytecode in order to perform the execution and all, but the size of DVM is reduced a lot more than the bytecode that has been developed by JVM. So in order to run on mobile phones, as we know, of course, as of now we see that mobile applications or mobile phones having so much of RAM available. You see 2 GB, 1 GB, 512 MB of RAMs, which is almost being equals to a laptop or a system configuration. But later, before, in the past, you have seen, and has to tell you that Android Zoom tablet is having only of 128 MB RAM, which was declared as the one of the best RAMs available for a mobile platform. So 128 MB RAM is not actually something is being acceptable by this generation, but when you talk about the applications framework and that level, it doesn't actually need that much. So by day it has been increasing its RAM because of the people requirements and necessities. Accordingly, the phone configuration is also being increased. So maybe Dalvik is not aware of that. So anyway, DVM will execute the code, and the bytecode that has been developed by DVM is far more less, or the size of this bytecode will be very less than the JVM bytecode. So that is why JVM comes into the picture in the middle, in order to get these core libraries getting accessed with the application framework. And all these things are actually in related. If you see, applications is getting related with application frameworks, and application frameworks are related with libraries, and libraries of course with the Android runtime and Linux kernel. So each and everything in the middle, there should be some kind of middleware in order to get accessed from one layer to another layer. So now application frameworks will access the libraries or the core libraries, whatever you may call it, is through Dalvik virtual machine. So, and there are few things in the application framework like view system. View system is very simple, that you see anything list, grids or text boxes or buttons that you see, or the browsers that you see in Android mobile phones. View system is responsible for that, which is present in application framework layer. And content provider, as we spoke in our very first example, it enables the application to access data. It could be pictures, it could be photos, it could be videos, it could be contacts, SMS, whatever it is. You can share own data into that, and wherever it is, so it can be retrieved again when you click on the calls or contacts through content providers. The pair itself actually is a self-explanatory content, which means in the mobile, what of the content you see, it's not something different that every day we see. It's photos, videos, contacts, messages, whatever, that all comes under the content. And it is a provider. It provides to whom or to what. It may provide the content to the application that you're calling from. For example, if you're calling from contacts, it doesn't give you pictures, it gives you contacts. If you're calling from gallery, it doesn't give you contacts, it gives you photos. So it depends upon the application through on which you're calling. You don't go to one gallery if you want to find someone's contact, or you don't go to call logs or contacts to find somebody's picture. So it's simple as that, and it's right. And resource manager is actually, it gives you non-core resources, which means localized strings, graphics, or layered files. In the sense, this can be very specifically explained when you see the Android file structure, which means Android file structure, when in the development you see two kind of things. One is .java files where the whole logic will be written, and another part is .xml part where the design part is present. And this design part is actually written or ended up with the extension .xml and saved in a folder called layout, and this layer folder is present in res folder. Res is actually stands for resource folder, where it will be managed by resource manager, which means that, for example, if you want to load any layout file from your Java code, so resource file will get to you on a single line. For example, set content view is a method that will get you the layout or the XML file that you want to load on your phone. So anyhow, we see that in detail in further classes. And notification manager. So on the top level, notification manager is responsible to display the custom alerts that comes. For example, you had an SMS coming to your phone, or any update to your application. So there should be some alert message coming to the phone in order to show you that you had an update or you had a message. So all that is being taken care by notification manager. And activity manager. And activity manager is one of the most important thing that we has to talk about, or anyone who actually wants to get into the Android development environments, because activity manager is actually responsible for managing the life cycle of an applications and providing a common navigation backstack. In the sense, you had been into different applications in your background, and some applications may be in the pause state, and some applications on a resume, some applications can get destroyed. So whatever it is, the application life cycle, whether it has to get resume or it has to get paused or it has to stop, everything will be taken care by activity manager. So activity manager will definitely is one of the important part we have to learn on in order to get into this Android application development, and it take care of the life cycle of applications. And let's go to the next one. And location manager. This location manager is one of the very most important things in today applications, which means that it will simply give you the present location of your phone. So which means that you could be anywhere on this globe. Your mobile phone can tell you where you are in the map, or where you are on this earth. It can give you the navigations and to reach your destination, as we are simply today everyone we're talking about GPS navigation, which has been enabled in mobile phones using location manager. Precisely, the location manager works with a chip present inside the mobile phone, which has been designed to get the lat long of your present mobile location. Lat long is location, lat long are the points, geological geo points, which something looks like 17.010 n degrees northeast, something like that. So which actually gives you the precise location where your mobile phone is present. In the sense, you are present, so you are never lost with this smartphone you had, or you are never going out of your route when you had this location manager in your phone. So all these things is being facilitated, or is being managed by location manager. Location manager is responsible to get your locations on the map, or in order to get you from one place to another place safely. And as we spoke, notification manager will give you the notifications if you had any messages or any missed calls or any updates that you had. So all these you actually see in your status bar. Of course, the screenshots which I am sharing to you would maybe looking a little bit older, but it is more sophisticated as of now. But it's the same location, it doesn't change the place, but thank God. And you see the no notifications on the very first screenshot where you had no notifications. But if you had any notification, it's get bulked with any kind of notifications, like USB connected. If your phone is connected to your computer or something, then it gives you that notification. And all this is being taken care by notification manager. And yes, how background app interact with users. For example, if there is a service running on your background which will share the notification, which will share the GPS location of your present place, or your present GPS points, geo points, when you are in a forest or you lost somewhere, and it gives you a notification in order to say that your particular service is active and your particular service has been disabled. It could be any service, it need not to be only the background service or background GPS service. It could be any service, which means that background services doesn't have any UI, so it will not be very feasible to understand to an user that whether the service is running or not. So he has to dig into the settings and check out that the particular service is running or not. But there is a chance of always knowing a particular service gone, or service is running or got destroyed by the notifications. So even there, of course, that has to be written in the background apps or the background services in order to show the user for a notification. In consistent notification presentation, which means that when we use some particular apps, I can name you that something like when your phone wants volume buttons to get acts as a power buttons, then you need to have some customized application in your phone, so which actually runs in the background every time to check whether you are is there any button pressed, or is there any volume button pressed, or something touched to lock your screen. So there will be always a consistent notification present on your phone notification bar, something always present, which means it can be never taken out or it can be taken out. There are two types of notifications again, which means user can completely taking it out after reading it, or it always present till that particular operation is finished. For example, if you have ever seen the Skype application, when you are actually talking a Skype application on your phone, the Skype application is always there, and even though you completely close your Skype application and you keep simply talking it, your Skype application running notification is always present in your notification bar, which means that even the application is closed and everything is closed, you are able to talk with the other person other side, which means that that particular application is running in the background now. So now whatever the notification that you see in the notification bar is called consistent notification. So you had consistent notifications and also inconsistent notifications. So how to write each one of them will go into further classes, and that's too early too. And view system, yes, the view system is something very much responsible to see the view is nothing but, in Android you can simply, at this level you can think that whatever you can see, so it could be text, it could be buttons, it could be text box, pictures, anything, however you put it, it's in the view system. So anything, if you're going to put, for example, you're going to put something on your XML, which is a design layout, you want to put up pictures, you want to put colors, you want to put text boxes, you're going to put everything in the view system. So view system is very much responsible for your view that comes out and shows you whatever thing you see on your mobile phone or in your applications is actually being managed by view system. And this is the other part, other example. And view system also consists of like list views, text views, and text boxes. Normally in Android called as edit text, but not text boxes, in order to give some isolation for other OSs maybe. And different text views, you can call them a text views, list views, grid views. So you find this is a list view, this is a America Samoa, and all this list is actually present in a list view. So list view is a separate component which can where you can simply use it to display a list of components or a list of text views, list of images, whatever it could be. List view is responsible for that. So list view is actually present in view system. So view system is origin for all these components. And let's come to the libraries which were there in the software stack, the same architecture. Now we were now we have spoke about applications and application frameworks. Now we are talking about libraries. So libraries, yes, you had different libraries for Android. You had library for each and every part, like you had library for SSL, SGL, OpenGL, Surface Manager, Media Framework, FreeType, WebKit, and SQLite. Each of it has been used wherever necessary. For example, OpenGL is actually used for a gaming application development, where you need an open graphics layouts and all in order to make a game ready, so which is very different from the normal application development in Android. And including a set of C++ libraries is also being used in components. As I told, libc is something that is a C++ library. All these libraries will be accessed by application frameworks by Dalvik virtual machine, and these were exposed only to the application developers or to the application framework. Even application developers will not completely can be accessing this without the application framework. In this sense, if you want to use something present in libraries, either you has to come from content providers or view systems or any other component that present in the application frameworks, but you can never go directly to the libraries and change something there or something you can use for your custom thing. So yes, this particular libraries part is a little bit well secured, and this gets updates or anything newly added components only when your mobile OS is getting updated and all, but not every time. And let's speak about the Android runtime, and which is also the part of libraries layer. So core libraries is providing the functionality available in core libraries of Java. For example, core libraries are nothing but the libraries like libc, WebKit, OpenGL, each and everything, and APIs like data structures, utilities, file access, network access, graphics, etc. So each and every part of the Android applications that you see on or actually get interrelated with each and everything. So the core libraries consist of all the libraries that actually you see on everyday applications, like data structures, where you use different kind of data structures like stack and all, each and every part of your phone. And utilities of file access, whenever you want to use some file that has been present in your mobile phones, you want to get retrieve that particular file, use file access. And network access, yes, there is different kind of network access APIs, like you can get it could be a Wi-Fi network, it could be a mobile operator network. So basically it is mobile operator network, and then the Wi-Fi drivers and all, you get the Wi-Fi network access as well. And graphics, yes, graphics is something which is more important to a phone, where when the UI is so sophisticated, obviously the user will be very much keen in using it. So graphics is also an important part of it. And Dalvik virtual machine is optimized for mobile applications. As you know, it runs multiple virtual machines effectively, and each app has its own VM. In the sense, whichever the byte code that I spoke about, which was being developed by DVM, or that was being converted into, it has minimal memory footprint, which means that the footprint that comes out of JVM is more memory occupying than the footprint of memory that has been occupying by DVM. So each and every app has its own VM. In this sense, virtual machine, it runs its own environment. So there is no such kind of thing like they get collide with each and every application. They had their own state, and they had their own segregation while running the application. There is no other application colliding with other applications. So Dalvik virtual machine is what actually does, you can see in the following picture. So .java is the file that you write, the complete code or the logical code that you write for Android, and it gets compiled by Java compiler, and there you get the dot class, which means the byte code. And now this byte code is something which is very similar to JVM or JVM generated dot class file, but this is very huge memory print or huge memory occupier than when you compare with the mobile applications, or where you had the low memory applications and or no low memory environments. So then DX, which means that Dalvik virtual machine, comes into the picture, and it converts this bytecode into .dex. So this is which will be running, or which is getting into the executable format, and this will be very easy to run, and relying on the Linux kernel, because the Linux kernel is used for is that low level memory management is very easy to get managed in Linux kernel, and threading concept is way lot bigger in Linux than any other OS. And generally Android applications are compiled to Dalvik bytecode in this way, like you write an app in Java and you compile it in Java and then transfer it to the Dalvik bytecode and load it into Dalvik virtual machine and the Linux OS. And continuing with the Android software stack again, and let's talk about the Linux kernel, which is the last part of the application Android software stack, and which is the last layer. And this had actually Linux kernel is of 2.6, the core system services relying on, and it had memory and process management, network stack, driver model, security, and whatever the core components or the driver level components are being managed in this Linux kernel. So are they really in the same way that they get in these layers? But they are actually only for the understanding purpose. But in order to understand the complete environment, how they work on, that is why we segregate them into different layers. So this memory and process management and network stack, driver model, you don't actually see them when you open up your mobile and simply look at the motherboard. You don't understand that where is the display, camera, keypad, Wi-Fi, or flash memory staying on. They are actually virtually present, so you can't actually relate this particular thing directly into the mobile phones, but you have to see the components that were there in each of it, is the architecture, how they has been managed. So each and every device, I mean any hardware that is present, or to a mobile phone, it could be audio or IPC or display, camera, keypad, Wi-Fi, each and every hardware device that is present on the mobile phone, it can be only integrated when there is particular driver model or network stack or process and memory management. So providing an abstraction layer between hardware and rest of the software stack is being done by Linux kernel. So it provides an abstraction layer in between hardware and rest of the software stack, which means that on above you have libraries and application framework and applications. So some applications may need the camera that has to be taking pictures, or example Beautify is an application that I know, which means which takes up the pictures and you can beautify the pictures. So which means that it opens up the camera, which needs camera driver for opening a camera. So you are actually accessing a camera application from another application. So where you need a match for both the applications, this can be IPC, which call as inter-process communication, where you talk about you talk to the completely different application, where you stand on a user application, you're talking to a core application like camera, and you're getting the data that has been processed by camera, and you're taking that camera footprint into your application, and you do any number of customization on that, and the rest of the part is left to the user. But generally in Linux kernel is something which is responsible for providing abstraction layer in between the hardware and the software stack. And network connectivity. So yes, Android supports different network connectivities. It could be GSM mobile phone technology, 3G, Edge, 802.11 Wi-Fi network. So each of this is actually a network protocol, where each of it is responsible for connecting to different networks. So that could be a Wi-Fi router, then it's going to be 802.11 Wi-Fi networks, and 3G and Edge is completely for the mobile operator networks, where you connect to a 3G or 4G or whatever you talk for today generations. And GSM mobile phone technology also had CDMA, TSDMA, HSPA, and different kind of protocols. So all those can be listed up here, because Android supports each and every part of the network support available or network protocol available. And yes, we are getting close into the development of Android, and if you're talking about the development requirements of Android, then you generally require Java and Android SDK. So yes, in order to have Java and Android SDK or the development environment, you can use Eclipse or Android Studio, that is directly available. And I suggest Developer Studio, that is available directly in the Android developer site, where you can simply get an exe, and you can in the exe for an Windows and respective files for other OS, and where you can simply install them directly, which had Java and Android SDK along with the executable files that has been provided by Android developer people. And in order to see the developer environment, we go further into the developer environment, and we can see prior to that. And let me tell you that there are two kinds of environments that you can develop Android for today. I'm telling you for today because there is a module called ADT, Android Development Tool, which helps you to develop an Android application in Eclipse. So the support that Android giving for Eclipse is being minimized these days due to more versions coming on, like till Marshmallow. So as of now, you don't see Marshmallow is supporting the Eclipse environment development. So yes, still you can develop the applications for your initial level in Eclipse, and then you can go on with the Android Studio if you are facing any difficulties. So Android application development can be done in Eclipse and in Android Studio. So in Eclipse, you need to download an ADT into the Eclipse and mount on it, and then download an Android SDK and mount it on Android SDK path, and you're good to go. So, and basically you need Java. So even behind Eclipse installation or Android Studio installation, along with the Android Studio installation, you don't need to download Java separately because it comes along with it. But for Eclipse, you need Java prior to that. You install Java first and then do the Eclipse download or installation. If not, it gives you error saying that it doesn't find any Java in your laptop or system. And let's talk about what Android SDK and Eclipse plus ADT consist of, or what is the present difference. So Android SDK actually consists of class libraries, which could be different classes that had all the classes that an Android application developer needs, of course legally needs. So, and developer tools, and there are different developer tools like UI animators or automators, which gives you different access to your applications, and emulators and system images. They are something that virtual phones, because if it is an web application, you can simply run it on any of the browsers and you can see the output. But when it is a mobile application, you have to finally check it on a device, or you have to make sure that it runs on a device. So you can't run it on a web application simply or on a window to understand that this application runs anywhere. So Android SDK provides you an emulator or system images which actually matches up with the real device environment, so that when the application is running, the application is running in some kind of environment where the mobile phone environment is being cloned. So you also consist of, you can be provided with documentation and sample code. You have some sample codes along with some documentation in order to read how and what these components work and what will be the best practices. And coming to Eclipse IDE, which is being recommended only for the initial development if you are going to use it, or else if it is always safe to go or recommended with Android Studio till today. So if it is Eclipse IDE, you need an ADT, Android Development Tools, first to get downloaded and should be installed into the or imported into this IDE or Eclipse IDE. You had different Eclipse IDEs till date. Mars, you can use any IDE above Galileo, so Galileo and above Galileo version. So you can use any of that IDE, and you can simply put the ADT development tools into that, install into that, simply going to the help and install new software. Give the link that is being specified in the Android developer site, and Android developer tools will come into the Eclipse now. And you need to download Android SDK separately and mount it on your Eclipse, and make the user interface and the creation is easier and application description is easier. Yes, when it is Eclipse, it's a lot more easier, but it goes on with the habit that what IDE you generally use. So Eclipse is something that very mostly used by Java developers, so that is why Eclipse IDE is being recommended for Android as well. But when you are from a different environment where you didn't work on any Eclipse IDE or any other IDE, it's better go to the Android Studio, which comes with IntelliJ IDE, and if everything is ready there, you can simply install once and you can start doing it immediately without any kind of ADT installations or SDK mounting. And here are the few advantages Android offers to you as a developer. So Android SDK is available for Windows, Mac, Linux, so you don't need to pay for a new hardware or start writing applications. SDK in the sense that SDK which is being given to you, or the classes which are being given to you, is not separate for Windows or Mac or Linux. So it's one and the same in all the three platforms. So you don't need to have a new hardware to write applications, unlike Mac. Because if you want to write iOS applications, you need to have a different environment. You should have Mac and Xcode in your Macintosh system, unless you don't be able to write any kind of iOS applications or Mac applications. So but Android applications, Android SDK supports in all the OSs, which means that you can make the development anywhere without any kind of difference, or any hardware without any kind of hurdles or any kind of problems. So the SDK that is being provided by Android is actually built on Java. So anyone familiar with Java programming language, you had very less amount of effort to be done. You are halfway there, so you don't need to do any much of deep digging to get something to get understood by Android SDK that's written in Java. So you can simply read them directly. And by distributing your application on Android market, it is available to hundreds of thousands of users instantly. So if you want, you have written some application and you get some idea using the Android SDK. Now you don't need any kind of environment or any kind of tools in order to market your application. You can simply use Play Store, which is called Android Market or Play Store. You can simply create an account, developer account, in order to put your application in the Android market. Of course, it takes $25 to create a developer account, and you can put any number of applications, and it's annual free, and you can put any number of applications. There is no power for putting these applications in that store. So once you put it there, you can simply take down the link and you can give it to anyone, or you can simply search in the Play Store. You can simply tell them or tell your friends to simply download them by searching that particular text. So that is not something we have to tell to this generation people. It's very easy to anyone who are having the phones on their hand. And you can for instance, you can release your application on your own blog. And it's not something that own blog, it had two kind of environments again: alpha testing and beta testing and production. Which means that alpha testing is something that you release the product only to the group of people. It's not completely into the other parts of the people who don't have access. And beta users could be some other premier users, so you don't make it available to all the users, but only to couple of users or some number of users. And production is something that it's available in the market for each and every person on this board. So there is no specific access. It is being accessed by anyone who had access to a Play Store. So as well as the technical SDK documentation, new resources are also published in Android developers as a platform gains. That means Android SDK is something not very rich. It keeps on updating its components by day. For example, when I started Android, there were only 2.1 and 2.2 versions. And if I see the development and updates, by now I have been reaching into Android 6.0.1, which means the marshmallow version. So you keep on updating your SDK. Of course, it keeps telling you, I mean, your IDE or Android Studio will show you a notification saying that you had an update and you can update it. So each and every release that comes, and that particular update is also being reflected in SDK. And application building blocks. Let's talk about the application building blocks. Application building blocks are like activity, intent receivers, services, and content providers. And let's talk about the very first thing called activity. So activity typically can correspond to one UI screen. In the sense, if you open your calls contacts or any application on your phone, you specifically see one screen showing up with some contents on your on it, which means that it has one UI screen. Activity generally will have an UI. It's not something that it doesn't exist a UI at all. It shows something on your screen. When an activity is open, on the screen showing up, but they can be faceless. In the sense, they can be sometimes a floating window, sometimes nothing on their face. In the sense it's a view. When I'm corresponding to one UI screen means it's a view that could contain a list or a text view or a button or a edit text or a grid view. It could be any component that is available. So sometimes activity can be nothing. It could be simple blank screen, something you see when you create a empty page, or when you open a simple empty page in a Word document. You simply see a page opened with a white thing. You can't say that a Word document isn't open. It's open, but it's faceless. In the same way, activities can be created or can be faceless, which means no components present inside.